In our last video, we dove into the world of sampling design. Now, we're tackling into sample size, which is the minimum number of participants or units you need in your study for your statistical results to be meaningful and trustworthy. If your sample is too large, you get great precision and less error, but it is very, very time-consuming, costly, and waste resources. But guys, if your sample is too small, it's an even bigger problem. You risk inaccurate results, more bias, and your study loses what we call power. This means your study might fail to give meaningful information. So, the goal sample size determination is to find the optimum number of participants or units that allows for appropriate analysis, provides a desired level of accuracy, and makes our statistical tests valid. So know how to get the right sample size in quantitative study. Okay, let's break this down into two ways. First, sample size based on population. Secondly, sample size based on variables using G-power. Now let's look at the first method, which is based on the number of population. You can simply get the sample size using a pre-calculated table, or else you can use online sample size calculator. There are three important things you need to know. First, your population size, the total number of people in the group you're studying. Secondly, your confidence level, how sure you want to be that your results are accurate. Typically, this is 95% or 99%. Think of it this way, a 95% confidence level means if you repeated this survey 100 times, the results would fall within your margin of error 95 times. Your margin of error, sometimes called the degree of accuracy, this is the plus or minus figure you often see in polls. For example, a 3% margin of error on a 60% result means the true value is likely between 57% and 63%. A smaller margin requires a larger sample. Let's do a quick example. Imagine you're studying student satisfaction at a university with 10,000 students. You want to be 95% confident in your results, and you can accept a 5% margin of error. If you look at the table or sample size calculator, you'll get sample size of 278. That's it? You would need to survey 278 randomly selected students. This number gives you results that you can be 95% confident are within 5% of what you'd get if you surveyed every single one of the 10,000 students. Alright guys, now let's move on to the method 2, sample size based on variables using G-power. When your research involves testing relationships between variables, like does training IV improve test scores, DV, you need a method that accounts for the sensitivity of your statistical test. This is where G-power software and power analysis come in. The key idea here is statistical power. Power is the probability that your test will correctly reject the null hypothesis. In other words, the chance it will find a real effect if one truly exists. We usually aim for a power of 80% or higher. Other key inputs are effect size and alpha level. Effect size standardized measure of the strength of the relationship or the magnitude of the difference you expect to find. This is where the nature of your variables and their expected relationship is quantified. Example, for the multiple regression calculator. Due to the exploratory nature of this study and the lack of prior research, a medium effect size of F2 as 0.15 was assumed for the sample size calculation. For the alpha level, A, the probability of a type 1 error, usually set at 0.05. If you're stuck between two methods, G-power or based on the population numbers, to determine your sample size. Here's some tips for you. Use the population-based method when your goal is description. You want to estimate a single thing for a whole population, like the average income or a voting percentage. Your key drivers are population size, margin of error, and confidence level. It's perfect for surveys and polls, but use G-power, the variable-based method, when your goal is testing a hypothesis. You're asking, does X cause Y? Or is A related to B? Here, the expected strength of that relationship, the effect size, is the most important driver. This is the gold standard for experiments and relationship studies. Choose the right tool for the job, and your research will be solid. See you next time.